Woohoo, we are live. This is Math 40 Elementary Algebra, and this is section 2.77, part 2. And we're working with inequalities. And what I wanted to do is I wanted to bring some superheroes back in. But because these are inequalities, I brought in the Hulk and Loki. And you can see that the Hulk has a height of A, and that is significantly bigger than Loki, who is much smaller. So I'm going to write A, the height of the Hulk, is greater than B, the height of Loki. And it's not even a greater than or equals to, it's a strictly greater than B. Now, what I want to do is I want to look at how their heights change according to what happens. For example, if they are both standing on a platform, and I'm going to say this platform is C high. Here we go. There they are, both standing on the platform. And I claim that on the platform, the Hulk is still taller than Loki, even when you take the whole height. So the Hulk plus the platform is still taller than Loki plus the platform. So in other words, A plus C, the Hulk plus C, this distance is C, and this distance is also C, and B plus C, A plus C is still greater than B plus C. B plus C is smaller than A plus C. So in other words, if I add the same amount to each side, the Hulk is still taller. So that's kind of cool. That's good to know. So the inequality A is greater than B continues to be true. The inequality sign still faces opening to the left. It's a greater than, even if I add something to both sides, as long as I add the same thing to both sides. Okay. Now, what if I put them both in a ditch? And just for the heck of it, I'm going to make this C tall or C deep. And if the Hulk and Loki are in a ditch, now here's the thing, if they're in a ditch, then I don't measure them all the way from the ditch. I would measure them from ground level, right? So from ground level, the Hulk is still taller than Loki. So in other words, if you take away C from both sides, this side is still going to be bigger. A minus C is still greater than B minus C. So I can subtract the same amount from both sides and not change the inequality, which means I'm not changing the truth of the inequality. Now it's going to get a little bit weird, but basically I'm going to take the Hulk and Loki and I'm going to clone them. So I'm going to make two Hulks. Ooh, I got to move this down a little bit. Move this down, move this over to the side. So we got lots of room. There we go. There's a pile of Hulks. And then here is a pile of Lokis. So if I do that, notice that now this Hulk and this Loki had a slight difference between them. This pile of two Hulks and this pile of two Lokis has a lot more, right? This distance is about half the distance. So in fact, and here I don't have room, but you could imagine if we did 3 or 4 or 12 of them, that no matter how many Hulks, if I have the same number of Lokis, so if I have C Hulks and C Lokis, then the Hulks are still bigger. But there's a caveat. C has to be a positive number. Why is that? Well, if C is 0, if C is 0, if I don't have any Hulks, then I have 0 Hulks and 0 Lokis. And if I have 0 Hulks and 0 Lokis, then nothing is nothing. So then the whole question becomes kind of silly. So you got to have at least something greater than 0 multiplied times them. So I've got a pile of Hulks and a pile of Lokis. That should be a movie. Pile of Hulks and pile of Lokis battling it out or fighting together. Something interesting, I'm sure. Eat marshmallows, roast hamburgers, something like that. So as long as C is greater than 0, if I get a pile of Hulks and a pile of Lokis, the pile will still be bigger than the Lokis. Now here's the thing you have to imagine. And this is going to take a little bit of thought, but can I convince you that even though I drew the picture with 2 Hulks and 2 Lokis, that even if my number over here were 2.3 and over here is 2.3, so if the C is multiplied on both sides, and you know what, I wrote this one in a way that makes it a little bit confusing. So let me, what? Is there a pterodactyl over there? What? Oh, I swear I saw a pterodactyl. There we go. So let me write it so there's more parallel structure. There we go. If I multiply both sides by C, C doesn't even have to be a whole number. C could be 1.8 and 1.8, or pi and pi. As long as I multiply both sides of the inequality, no longer an equation, but now an inequality, as long as I multiply both sides by the same number, and that number is not 0 and not negative, so it's positive, we're golden. The inequality stays true. Now the weird one. You guys ready for the weird one? The weird one is the monkey bars. That's what they used to call it when I was little. Monkey bars. And I think the suggestion was that children sometimes jump and swing around like monkeys. I think that was the goal, to liken us to like spider monkeys. So we're going to take the Hulk and Loki to a playground in the 70s. And in the playgrounds in the 70s, we had lots of dangerous things to do. And one of the dangerous things we had to do was they just put up literal metal bars and they said, go have fun. And we would hang upside down. We'd do spins. We'd jump off. Sometimes we'd break our arms. It was really, the 70s were amazing. And I'm very sorry because many of you watching this video, you can only dream about the 70s. It was an amazing, amazing time, except for the bell bottoms. We should not speak of the bell bottoms, but everything else was amazing. So also the avocado colored furniture was a little weird, but okay. So we got the Hulk hanging upside down for the monkey bars, and we got Loki hanging upside down for the monkey bars. So what the heck is this representing other than superheroes going to the park? And the answer is, well, this is what I think it looks like when you multiply by a negative number. You flip everything upside down. Now, this is a -1. I've multiplied by -1. And so what has happened is the Hulk is taller. So notice that if we look at the top of his head, we see that it's actually hanging shorter than Loki's head, which is hanging higher up. Because Loki is shorter, he can't hang down as far. So technically, Loki is bigger at this point. In other words, his eyes are at a higher level than the Hulk's eyes, which is a little bit weird, I know. But what I'm saying is, if I multiply, say, by a -1 times A and a -1 times B, I claim that that changes the inequality. The inequality now opens to the left. Or sorry, to the right, from the left to the right. So in other words, if I multiply the left and the right by a negative, the inequality changes around. Remember before, Hulk was bigger. A is greater than B, but in this picture, a number times A is less than a number times B if that number is negative. And this problem on this one that we just did, this is C is positive. So if positive number doesn't change the inequality, negative number changes the inequality. Now, I only showed you one because my monkey bars aren't that big. But if I had a really big set of monkey bars, we could do a lot of Hulks and a lot of Lokis. And you could see that because Loki is short, he doesn't hang down as far. And so technically remains taller when he's upside down. So let's take a break from the Hulk and Loki and let's come over here. I claim I've got a true statement. 10 is greater than 5. 10 is greater than 5. And I'm not trying to trick you. This is absolutely true. Would you rather have $10 or $5? Well, give me $10. That's better than $5. So 10 is greater than 5. What happens if you multiply both sides by 2? So I do 2 times 10 and 2 times 5. 2 times 10 is 20. 2 times 5 is 10. If I multiply both sides by 2, then I get 20 and 10, and that stays. See how the inequality stays facing the same direction? And let's start over here. Let's start 10 is greater than 5, and let's divide by 5. So let me do that in pink. So 10 divided by 5 and 5 divided by 5. There's my pink right there. What's 10 divided by 5? 10 divided by 5 is 2. 5 divided by 5 is 1. Inequality stays the same. The inequalities are unchanged. And by that, I mean, obviously the numbers are different, but the inequalities continue to face in that same direction. Now, what happens if you take 10 is greater than 5 and I multiply by -2 on both sides? Okay, let's do this one in orange. Multiply both sides by -2. There's my -2 and my -2. So what happens? -2 times 10 is -20. -2 times 5 is -10. Now which is different? Which is different? Now which is greater? You got it. $10. -$10 is actually greater than -20. The inequality got switched around because when I multiply by a negative, suddenly I turned $10 into a negative number. So I flipped it upside down. And so now I owe $20 or I owe $10, and this one becomes bigger. It's better to have -10 than -$20. Let's try, let's see, I need another color. What if we divide by -5? Okay, so I've got 10 is greater than 5, and if I divide by -5 on both sides, 10 over -5 is -2, 5 over -5 is -1. Happened again. When I divide both sides by -5, my inequality changed directions. So if you multiply or divide both sides by a negative, and what we say is we say flip the inequality. So in other words, the inequality goes from being a greater than to a less than, or it could go from a less than to a greater than, depending on your perspective. Kind of, sort of, woohoo. So this is the big rule. It is only with multiplication or division. Remember that adding, subtracting do not change the Hulk and Loki. The only thing that changed is when you actually multiplied, so you flip the numbers themselves upside down. Okay, shall we give this a try? Let's try out a bunch of problems. Woohoo! Okay, here we go. Let's solve for x. Now notice that when I say solve for x, I don't specify how your answer should be, which usually means just leave it in an inequality form. If you also want to graph it or find an interval, awesome, but read the instructions carefully. If it just says solve for x, then you just write the inequality. So I've got x plus 3 is greater than 5. What should I do to both sides? Well, some people panic because they're like, you didn't tell us how to do inequalities. And the answer is yes, I did not. However, Inequalities are solved using the same steps as equalities, equations. So if I've got x plus 3, I want to do the opposite thing. So I'm going to subtract 3 from both sides. And just like we did before, we draw the dotted line. And if you hate that, don't do it. But basically, you have to make sure there's a negative 3 on both sides. On the left, I've got an x because these cancel. And on the right, I've got 2. And if I'm subtracting, the inequality stays the same. I don't do anything special to the inequality. Second one down, 3x is less than 6. Okay, so we think about it. We're like, okay, 3x is less than 6. What's between the 3 and the x? It's multiplication. So what's the opposite thing? Division. So if I divide by 3 on the left, I divide by 3 on the right. Now I'm dividing by a positive number. Inequality does not change. And so I get x is less than 2. What do you guys think? Woohoo. It started with a less than, it ends with a less than. Started with a greater than, it ends with a greater than. Oh no. So I've got negative 3x is less than 6. I've got a negative 3 here. I'm going to go ahead and divide. Now, if you watch the video and watch how I do this, you'll notice that my first step is not to write in the inequality. My first step is to write on both sides what I'm doing. And then I think about it. And I was like, this is dividing by a negative. Since I'm dividing by a negative, I need to change the inequality. So then over here, I've got x is greater than, and this is negative 2. Notice that when we had to divide by a negative number, we had to flip the inequality. Okay. So we have got a good number more of these that I want to get through. So I'm going to stop right here because we're at 17 minutes, which is plenty long for a video. In the very next video, we will start doing some far more exciting, spoilery problems. We will do those next. But for right now, woohoo, you guys are awesome. And I will see you in the next video. Woohoo, math on, guys, math on.